The mean and standard deviation of 100 observations were calculated as 40 and 5.1 respectively by a student who took by mistake 50 instead of 40 for one observation. The question is, what are the correct mean and standard deviation? So we had 100 observations and we figured out the mean and standard deviation for all 100. One of those observations was actually 40 and we took that as 50 by mistake. So we have our incorrect mean as 40 and our incorrect standard deviation as 5.1. From this, we have to figure out the correct mean and correct standard deviation. Pause the video, try this out. Alright, let's do this together. Mean is 1 by n summation xi. That's sum of all the observations divided by n. Now n is 100, mean is 40. This can help us figure out what the incorrect sum of all the observations is. So that's 40 equals to 1 by 100 times summation xi. This means summation xi is 40 times 100, that's 4000. Or we can say that our incorrect sum of all the observations is 4000. So when we were figuring out our mean and standard deviation, because of our mistake, we took the sum as 4000. We can fix this. What's the correct sum of observations? Okay. For the correct sum, we have to fix our mistake. We'll subtract 50 and add back 40. So our correct sum of observations will be incorrect sum minus 50 plus 40. That's going to be 4000 minus 50 plus 40. That's 4000 minus 10. That's going to be 3990. So this is our correct sum of observations. We have no idea about the remaining 99 observations, but because we know that we have this one mistake, we can fix it and figure out our correct sum of observations. Alright, let's talk about standard deviation. The formula for standard deviation is root of 1 by n summation xi square minus 1 by n summation xi whole square. If we took 50 instead of 40, where do we see the mistake happening in this standard deviation formula? We can see that the mistake happened twice in the standard deviation formula. One mistake is in summation xi, which is sum of all the observations. And the other mistake is in sigma xi square, which is sum of squares of all the observations. Both of these would have been entered incorrectly. Let's rewrite this. 1 by n summation xi, that's actually our mean. So 1 by n summation xi square minus mean square root is our standard deviation. This is 5.1. That's equal to 1 by n times incorrect sum of xi squared. This part is incorrect minus incorrect mean. That's our 40. So 40 square. So from this equation, we can get the incorrect sum of squares of all the numbers. So let's figure that out. Let's square both sides. Square of 5.1, that's 26.01. That's equal to 1 by 100 times incorrect sum of squares minus 40 squared, that's 1600. We can add 1600 to both the sides and then multiply by 100. That's going to be 1626.01 times 100. That's going to be 162601. So our incorrect sum of squares for all 100 observations, that's 1,62,601. Now, how can we get the correct sum of squares? We can fix our mistake. We would have added 99 values and then for the 100th value, which was 40, we added 50. So instead of adding 40 square, we added 50 square. So to fix this, we subtract 50 square and add back 40 square. So our correct sum of squares for all 100 observations is going to be our incorrect sum of squares minus 50 squared plus 40 squared. So that's going to be 162601 minus 2500 plus 1600. So that's going to be 900 less than this. That's 161701. So this is our correct sum of squares. Now we have the correct sum and we have the correct sum of squares. We can figure out the correct mean and the correct standard deviation. So let's do that. Let's first figure out the correct mean. That's sum of all the observations divided by total number of observations. That's going to be 3990 divided by 100. That's 39.9. So our correct mean is not 40, it's 39.9. And what's our correct standard deviation? So our correct standard deviation is going to be 1 by n summation xi squared minus mean squared. So if the correct mean is 39.9, we can simply write this as 39.9 squared. And the correct sum of squares is 161701. Let's divide that by n, which is 100. So our correct standard deviation is root of this. That's going to be root of 1617.01 minus 1592.01. And if we simplify this, we'll get root of 25, that's 5. So our correct standard deviation is actually 5.